This video demonstrates a simulation platform developed in the N4C project for testing applications for delay-tolerant networks. The idea is to simulate the physical layer in the NS3 simulator while testing actual applications and protocols on virtual or physical nodes. In the first example, we'll send DTN messages from 3 virtual nodes on Linux containers to one real phone, which participates in the network via Wi-Fi. The windows at the top left are for visualizing and control. The window on the bottom left is a remote view of the actual phone display delivered out of band via a USB cable. The windows on the right show Linux command lines on the virtual nodes. The virtual nodes use the DTN send program to send DTN bundles, while the DTN receive program on the phone waits for them to be delivered. Transmission occurs when a node moves close enough to its neighbor. In this example, we control the moves interactively. With the first 2 bundles shown, after firing up the DTN send programs, they are sent as soon as the sender and receiver nodes come into range and discover each other. The third bundle goes a different way. The sender and receiver nodes do not have a direct contact. Instead, another node takes on the role of a data mule and relays the bundle from the sender to the receiver. With more complex scenarios, some automation of setting up simulations can be useful. Here we are going to run 50 Linux container nodes, 2 VirtualBox nodes and 1 real node connected over a VPN. A configuration file with simulation parameters will be read in, as well as a simulation scenario file, which defines the positions and mobility patterns of the nodes. The automation layer of the platform creates or clones the necessary network interfaces, network bridges and virtual machines and connects them, all according to the configuration and scenario files. The windows are opened as needed and the DTN daemons are started up on the nodes. The visualization window appears, waiting for the operator to manually start the actual simulation by pressing the Simulate button. This particular setup shown consists of a group of stationary nodes and some mobile data mules, which move according to a pattern resembling scheduled bus round trips. The node positions, movement and data transmission between them are all shown in the visualization window. In addition to that, they are all recorded in log files for further analysis. We can observe the simulation as it runs, zoom in and out, stop and rerun it. The states of all the nodes can be saved between the simulations. On completing the simulation, the automation layer tears down all temporary network connections and removes temporary objects. Next, we modify our simulation setup by selecting a different predefined scenario and increasing the number of Linux container nodes up to 90. This, by the way, places not that much burden on the simulation host computer. The Linux container virtualization is lightweight, and the resulting random access memory usage increase is of the order of 100 megabytes, while the disk space usage increase is hardly noticeable. The pattern of movement of the data mules in this simulation is different. Their trips are now random instead of bus-like schedules. The main application area for the simulation tool is the integration testing of DTN applications. Physical test beds for such applications are often in remote areas, hard or costly to access, so it's vital to test interactions of the components thoroughly before going out to field tests. The tool models the physical DTNs up to the data link layer. The higher-level DTN protocols, for example routing, as well as applications, are not modeled. Instead, their actual implementations are employed in the simulations. These may be in the form of actual implementations run in virtual machines on the simulation host, or of whole real hardware nodes, for example smartphones, PDAs, netbooks, routers, each with their own native software, because the primary objective is to observe the real applications and nodes in action.